Okay, the next several videos I'm going to be doing are examples. So I want to describe the end behavior of the following functions. So first of all, I'll take a look at f of x equals 3 minus x over x squared minus 1. So if I want to look at the end behavior, what I need is the limit as x goes to infinity of 3 minus x over x squared minus 1. Now, this is equal to the limit as x goes to infinity of 3 minus, I need to figure out what I'm going to do here. And what I'm going to do is I'm going to divide the numerator and denominator by x squared, the biggest part in the denominator here. So I get x over x squared over x squared over x squared minus 1 over x squared. This reduces, this is the limit as x goes to infinity of 3 minus, the numerator is 1 over x squared. The denominator is 1 minus 1 over x squared. I'm sorry, this is 1 over x, not x squared. There we go. Now I can take the limit. Now notice before, if I simply took the limit here, this limit would have given me 3 minus infinity over infinity. Well, I don't know what the heck that is. Again, this is that indeterminate form that we need to do a little bit more work on. So now if I take the limit as x goes to infinity of 3 is just 3. 1 over x goes to 0. 1 is just 1. 1 over x squared goes to 0. So what I end up with is 3 minus 0 over 1, which is obviously 3 minus 0, which is simply 3. So the limit as x goes to infinity is 3. This suggests that I have a horizontal asymptote at y equals 3. Now what happens if I go the other way? If I take a look at the limit as x goes to negative infinity of 3 minus x over x squared minus 1, what's going to happen here? Well, this is going to be equal to the limit as x goes to negative infinity of 3 minus x over x squared over x squared over x squared minus 1 over x squared, which is equal to the limit as x goes to negative infinity of, I have 1 over x squared, I'm sorry, 1 over x, gosh, I keep doing that. There we go. Over 1 minus 1 over x squared. Well, now in the limit, oops, I missed my 3. I should probably put that 3 back in there, huh? So let's erase this real quick. And see, I'm going to have 3 minus 1 over x over 1 minus 1 over x squared. Now, as x goes to negative infinity, this piece will go to 0. This piece will also go to 0. So I end up with simply 3 minus 0 over 1. Change colors there, which is simply equal to 3. So the horizontal asymptote for positive infinity and negative infinity are in fact the same thing. So asymptotically, this function goes to 3. And very quickly, let's whip it up in Maple. There it is. You can see as x goes to infinity, this levels off and goes to 3. And this goes to also to 3. And I'll go ahead and toss in there the horizontal line, y equals 3. And that should help convince you even more. Graphically, it looks like they are approaching 3, regardless of whether I'm going to positive infinity or negative infinity.